Hey everybody, so I have an irrational fear. Oh my gosh, it's getting so loud. Hello? Can you hear me? Can we turn it down? Can we turn it down a little bit, please? Oh, thank you. No, down. Further. Keep going. Oh, thank you. Okay, now that everybody can actually hear me, let's wind it all the way back and start the whole thing over again at a much more appropriate volume. I need to start out by saying I have a deep love for IoT devices. I know they get a bad rep because they're slow, things go to the cloud, they're not always stable, companies lose your data. However, in today's world where modern computing is so dirt cheap and you can get devices like an ESP8266 for pennies on the dollar practically, you can make your own IoT devices and keep everything local, keeping it secure, fast, reliable, stable. So that's exactly what I did. Welcome to an IoT project on how to avoid skin cancer. So what are we going to need? We're going to need at least two ESP8266s, probably a 1.5 amp USB, DC, and solar charger, an ALS plus UV sensor, a couple LiPo batteries, some solar panels, and quite a bit of time. We're going to combine all of these in order to grab that UV index from outside, hand over the information to a Home Assistant server, use that server to process the information, ask Google using their text-to-speech software to send that text over to a smart speaker, read it out to us, send a quick notification to a phone, and then know if we only need to wear a hat or grab that sunscreen bottle. Okay, first things first. We're going to have to create something to house that weather station and house the sensor that goes onto the door to actually trigger all those events to take place. We're going to head over to my current favorite modeling software called Onshape. Don't look. Definitely doing this for the first time. And wada bing, wada boom, wouldn't you know it, there it is. All of its glory. Everything has its own little spot, unique little place to go. This is a good time to mention that I also took the time to throw in a BME 280 into it because that sounded awesome. And through the magic of movie editing, the door sensor is also done now. I had it set up so that the ESP8266 actually sits on top of the LiPo battery just to be a little bit more compact because it is going above that door. The holes in the side of it are designed so that the door sensors can come out of it. Now that everything's been designed, we just need to slap them over to the 3D printer. Unfortunately, I forgot to get video of it printing out, so here's just a beautiful picture of my 3D printers sitting doing nothing. However, here is the final result of them being printed out. And as you can see, this is where the big first mistake I realized came in, is that I made those screws way too tight against the edge of the actual casing itself. And so if I had to come back and redo it again, I would absolutely just expand that edge out a little bit. Are you still paying attention? Okay, good. Come closer. Let me tell you a secret that Google and Amazon doesn't want you to know. There has been so many tools built to help you get started building your own IoT devices, and this is no exception. We are going to use ESP Home and connect it back to Home Assistant again. So all of the complicated C++ programming has been, the majority of it, done for us. And we just need to enter this code into the actual main board, which will then allow us to trigger all of those automations based on the door opening. Once we have that code uploaded to the ESP8266, we just need to check those logs, make sure that they're looking good, connected to the right Wi-Fi, hook it back into Home Assistant, write a little bit of YAML code to do the automation based on the triggering event of the door opening, pump that into historical graph data so that we can track it over time, maybe make a nice little Home Assistant card for it on the front screen, and then we'll be good to go. Now all we have to do is run a quick automation test and it should all go... Oh. Huh. Well, that didn't go to plan. Alright, let's head back to the automation and try again. Okay, that took longer than I was expecting. However, the bug was I messed up the naming of the service to call because I thought it was a numeric stake. However, I have it set up to be high and low for the UV. But now that we've pinned it down, We are good to go. Run a quick automation check, and that's what I'm talking about. All right, so now we just have to go physically open the door to double check that it's working and go from there. Okay, here we are. The final build is up there. It should be triggered when we unlock and open the door. Sweet, everything went off without a hitch. I got a notification on my phone. Looks good to go. So now that it's all done, I'm sure you're thinking it's all sunshine and rainbows and everything went perfect. Well, sadly, that's not true. I ran into a couple weird issues with the hot glue that I first used to hold the solar panels onto the actual weather station. Ended up turning like this, which was weird. So I had to scrape it all off, which was just fantastically fun, and put new UV resistant hot glue on it. So we'll see how long that one holds for. The sensor where I put it on the door actually kind of hits it on the way in and out. So hopefully that holds up over time. I'm honestly not too sure. And the only other thing that I would like to add in is to have the weather read off to me as well, since I did put that BME 688 in there. So it would be nice to have the weather and UV index read off all in one kind of go. Wow, we're finally at the end of the video. Thank you so much for watching everything. I think it was great. I really want to thank... Hey, no, turn down the volume. I still talk. Whatever. Bye.